All right, engineers, welcome to the bench. Today we're getting our hands dirty with the X43 It's a multi-constellation RTK receiver, and it's built for high-precision stuff like UAVs and robotics. So we're going to break down exactly what it takes to get this piece of hardware designed into a real-world system.
You know, as hardware engineers, whenever a new component like this lands on our bench, there are a few critical questions that always come first. Will it actually fit in our design? How do we talk to it? And of course, what's it going to take to power this thing up? Getting these fundamentals right, well, that's what makes or breaks the entire integration.
So let's crack open the datasheet and do just that. We're going to break down the physical side, the electrical interfaces, and really see just how easy the folks who designed this made it for us to integrate into a system.
Okay, first things first. Before we get into any of the fancy electronics, we have to ask the most basic question. Will it fit? We're talking about the physical envelope, the size, the weight, the mounting. This is always gate number one, especially when you're working on something like a drone, where every single gram and millimeter is precious.
And here they are, the mechanical drawings, straight from the source. These are the numbers we absolutely need. You pull these right into your CAD model to check all your clearances and start designing the enclosure. And as you can see, everything is spelled out for us, nice and clear.
So here's the takeaway. At just under 44 by 34 millimeters and weighing less than 25 grams, that's incredibly small and light. For any kind of payload-sensitive application, like a commercial drone that needs to stay in the air as long as possible, those are beautiful numbers to see. Okay, so it fits mechanically. Check. The next huge question is connectivity. How do we get data in and out? A reliable I/O is really the heart of any sensor integration. So let's take a look at the actual physical ports on this thing.
So, looking at the outside of the box, the I/O is really straightforward, which is great. We've got a modern USB Type-C port, awesome, that can handle power and data, and right alongside it you've got two dedicated I/O connectors for good old-fashioned serial communication with our other embedded hardware.
And if we look closer at the pinout, this is exactly what an engineer loves to see. No proprietary weirdness, just two standard TTL-level UARTs with dedicated transmit and receive lines. This is just perfect for hooking directly into a flight controller, an autopilot, or really any other microcontroller you have in your system. It's a piece of cake.
Now, check this out. This is another key feature that's a huge plus, a built-in TF card slot. This is fantastic for data redundancy and any kind of post-mission analysis. It lets you log all your raw SBF or NMEA messages right on board, on cards up to 32 gigs. It basically means you have a rock-solid backup, and you're not totally dependent on your main computer to capture that critical positioning data.
All right, last but definitely not least, let's talk about power, the electrical requirements. This is where we get into the nitty-gritty for our power budget and designing our power delivery network. And as you know, getting this right is completely non-negotiable for system stability. So the datasheet gives us a really wide power supply voltage range, all the way from 3.5 up to 12 volts. Now, as a designer, that kind of flexibility is just fantastic. It means you can power it from a common 5-volt rail, or you could tap into a higher voltage bus, maybe from a 2S or 3S LiPo battery, and just use a simple regulator. It really simplifies your power design.
Okay, but let's talk power consumption. A typical draw of just 95 milliamps at 5 volts while it's tracking, that is exceptionally low. For any system running on batteries, like a drone, that number is absolutely critical. See, lower power consumption directly translates to longer mission times, more endurance. This is a huge win for the overall power budget.
So, let's wrap up our hardware deep dive. The X43 it really presents a super straightforward integration path. From an engineer's point of view, it just checks all the right boxes, It's compact, it's lightweight, it has standard and really versatile data interfaces, and it's incredibly power efficient.
So, at the end of the day, with its really well-thought-out physical and electrical design, the X43 proves to be a rock-solid foundation for pretty much any project. It's just an excellent candidate for providing that critical, high-precision positioning data that you're going to need for your next industrial drone or autonomous system.